solve the inequality, write answers in interval notation. So for part A, you see that on the left side we have there's a polynomial on top and one on the bottom, and the sign, we have a greater than or equal to 0. So the first thing that we want to do, since this is an inequality, we're going to end up with portions of the number line that indicate where our solutions lie. Those would be the intervals. And this number line is going to be broken up into intervals based on the critical values of this function here. So starting with the top, I'm going to set the top, the numerator, equal to 0 plus 6. And then solve this for x. So when I factor this, I get x, let's see, x minus 2. This factors in x minus 2 times x minus 3 equal to 0. So the critical points here that I get from the numerator is x equal to positive 2, and then the other one is x equal to positive 3. And I can come over here on my number line, and what I want to do is indicate or mark those off. And take a look at the inequality sign that they give us here. It's a greater than or equal to, so that means I can include these values because, remember, this is in the numerator. So if I plug in a 2 for x, it will result in a 0 on the numerator, which will result in this whole left side going to 0, which gives me a true statement. So I can include those. All right. So now let's take a look at the bottom, okay, to find out what x values would cause the bottom to go to 0. X squared plus 10x plus 25 equal to 0. This factors out to be x plus 5 times x plus 5 equals 0. So then x is just going to be equal to negative 5. That's our other critical value. Now let's take a look again. This is in the denominator, so if I plug in negative 5 here, I'm going to get something undefined. So I don't want to, in my solutions, I'm not going to include the value of negative 5. I just want to go up to it, so I have to put an open circle there. All right, so now you see my number line has been broken up into 4 sections. The section here, negative infinity up to negative 5 up to positive 2, 2 to 3, 3 to positive infinity. So I have to determine which one of these intervals are valid intervals that will make these this inequality a true statement. So let's start with this first interval, and I will plug in we'll start with this first interval, negative infinity up to negative 5. So I'll choose a value from that interval, and let's say f of negative 6. Okay. So in the interest of time, if I plug in f of negative 6 into this function here, I'm going to get, let's see, it results in 72 on top and then 1 on the bottom, which equals to 72. And so 72 is greater than or equal to 0. So I get so yes. So I can check this off that is a valid interval. So the second section, I'll go to f of, let's see, I'll use f of 0. Okay. So when I plug a 0, then on top I get 6 over, and on the bottom I get 6 over 25. All right, and so 6 over 25, that's a positive value, so it's definitely going to be greater than or equal to 0. So once again, I have a valid interval. So for the third section, I go f of, so I don't have much space here, so I'll just choose 2.5. Okay. And then when I plug this into my function over here, I end up with, on top, negative 0.25. over 50, positive 56.25. So this is going to result in a negative number. I have a negative being divided by a positive. And is a negative going to be greater than or equal to 0? No, that's not going to work. So I'll put an x here. And then finally, I check the last interval, and I'll take f of 4. And I get a positive 2 over a positive 81. So this is going to be a positive value, and that will definitely give me a true statement, definitely greater than or equal to 0. So I can include this last interval. So now let's put all this together and write this in interval notation. So I go from, let's see, negative infinity up to negative 5, all right, but I don't want to include it, so that is a parentheses. This is union with negative 5 up to 2, but I want to include it, square bracket, union with 3 up to positive infinity. Okay, so here's our complete answer in interval notation.